Okay, so in my well plate here, I have 6 different chemicals. You might want to write this down, which chemicals I'm testing. I'm doing bleach, which is a household cleaner. I'm using a solution of sodium hydroxide, which we make here at the lab. Then I have some magnesium hydroxide. This is actually commercially used as an antacid. This is milk of magnesia. Then I have some vinegar, regular old household vinegar. Here's the solution of hydrochloric acid, which again we would make here in the lab. And then we have distilled water. Distilled water, of course, has been boiled to remove any impurities or ions that might be in it. So this would be just straight pure water. I've only brought my 4 favorite indicators and then my indicator papers as well to show you. The first one is phenolphthalein. This is what we will be using for the fruit juice titration. It is pink and clear, bromophenol blue, blue and yellow. Universal indicator is a rainbow of different colors. And then cabbage juice, this is actually one you can make at home. So if you ever wanted to do some acid-based testing at home just for fun, you go and get a red cabbage, chop it up into little pieces, and then you put it in a stock pot with water and you boil the water for like 15 minutes and then strain out the cabbage juice, and that is cabbage juice indicator. And then there are test papers that we're going to do. We're going to do blue litmus paper, which in a base won't do anything, but in an acid it'll turn pink. Red litmus paper, that will do nothing in an acid, but in a base it will turn blue. And then pH paper, which turns these different colors depending on its level of pH. So I'm going to start with the pH, or with the indicator papers. So let's start with the blue litmus paper. I'm going to test my distilled water first. My blue litmus paper didn't really do anything. Red litmus paper, not much there either. And then my pH paper, if we look at our scale, that is pretty spot on at 7. Pretty close to a pH of 7 with our pH paper for the distilled water. All right, let's take it down the list. Phenolphthalein. A couple of drops there. Not much of a color change. The bromophenol blue. The universal indicator. And our cabbage juice. So for the most part, it's looking like it's staying a pretty neutral color, which is what we would expect out of water. All right, let's try our HCl solution. Let's do our paper tests first. Let's do our blue litmus. Ooh, nice and red, which is what we would expect from an acid. We would expect an acid to turn that nice and bright red. Our red litmus paper, we wouldn't expect a change here. Okay. Our pH paper. Ooh, right there, all the way to a pH of 1. Okay. Let's try our phenolphthalein. Should be clear. Acids are usually clear. Okay. Bromophenol blue. Ooh, nice pretty yellow color. Universal indicator. Nice bright pink color. And then our cabbage juice. Nice pink color. All right, let's test our vinegar. So hydrochloric acid is a nice strong acid. Let's try a weaker acid. Vinegar is a weaker acid. Let's start with our pH, or our litmus papers. Blue litmus paper, this should still turn red. Now you'll notice it's not nearly as red as the strong acid was. Much less red, but still definitely red. Our red litmus paper, again, this probably shouldn't do anything. Our pH paper. Hanging out more around a 3, getting closer to between the 3 and the 5. Okay. Phenolphthalein. Still should be clear. Bromophenol blue. Still a nice yellow. Universal indicator. Still kind of a reddish color, but more leaning a little closer to the water's color than to the acid's color. And then our cabbage juice indicator. Not as pink as the HCl, but still a nice pink color. All right, so now let's switch over to the more basic end of things. We have magnesium hydroxide, which is a weak base. So not much expected with the blue litmus paper, because blue litmus paper turns red in acids, but nothing in bases. The red litmus, hard to tell because it's white. Maybe a little hint of blue there. Let's try our pH paper. Ooh, nice. Let's get some of that white stuff off. So we're hanging out right around a 9 here. Okay, let's try our phenolphthalein. Ooh, that turns a nice pink color. Bromophenol blue. Nice purple. Universal indicator turns all sorts of colors. Kind of a greenish, like a darkish blue-green. And then our cabbage juice. Looks like it's kind of hard because it doesn't really want to mix. There we go, kind of a bluish color on the cabbage juice. All right, let's try our sodium hydroxide solution. This is a strong base, so our blue litmus paper shouldn't do anything. Red litmus paper should turn blue. Nice blue. There we go. Our pH paper, let's give that a test. Ooh, yeah, right there at the 11 color. Okay, which makes perfect sense for a nice strong base. All right, let's do our phenolphthalein. Ooh, nice bright pink. Our bromophenol blue. Ooh, nice pretty purple color. Universal indicator. Ooh, nice pretty dark purple. And then our cabbage juice indicator. Ooh, look at that pretty green. All right, the last one we want to test is our household bleach. Okay. Ooh, looks like it's going to be basic. Our blue litmus paper did nothing. Red litmus paper, not much of a change. Our pH is hanging out kind of between 7 and 9. It's not quite dark enough to be a 9, but not quite light enough to be a 7. All right, let's do our phenolphthalein. Nice and pink. Bromophenol blue. Nice pretty purple. Universal indicator. Nice green color there. And then our cabbage juice indicator. Nice green color. Okay, so you'll notice that Our pH paper, nice range of colors. Litmus paper is kind of a good either or. Phenolphthalein is either clear or pink. Okay, bromophenol blue is either yellow or blue. Universal, we get a bit of more of a range of colors. And the cabbage juice, we get a bit more of a range of colors as well.